Russian scientist Gamov calculated by the time it crossed the vastness of the cosmos, the radiation which reached Earth in the form of microwaves. In a more recent paper, he even suggested an instrument that might be able to do the job, the Bell antenna at Holmdel, New Jersey. Unfortunately, neither Penzias or Wilson, nor even the Princeton team, had read Gamov's paper. The noise that Penzias and Wilson were hearing was, of course, the noise that Gamov had postulated, the noise from the Big Bang creation. They found that at the edge of the universe, or at least the visible part of it, 90 billion trillion miles away, they were seeing the first photons, the most ancient light of the universe, through time and distance, and converted them to microwaves, just as Gamov had predicted in his book, The Inflationary Universe. Alan Guth provides an analogy that helps us to put this finding in perspective. If you think of peering into the depths of the universe as looking down from the 100th floor of the Empire State Building, with the 100th floor representing now, and the street level representing the beginning of time, at the time Wilson's discovery, the most distant galaxies anyone had ever detected were on about the 60th floor, and the most distant things, quasars, were on about the 20th floor. Penzias and Wilson's finding pushed our acquaintance with the visible universe to within a half inch of the sidewalk. Still unaware of what caused the noise, Wilson and Penzias phoned Dickey at Princeton and described their problem to him in the hope that he might suggest a solution. Dickey realized at once what the two young men had found and declared, "Well, boys, we've just been scooped," he told his colleagues as he hung up the phone. Soon afterward, the Astrophysical Journal published two articles, one by Penzias and Wilson, describing their experience with the HISS, and the other by Dickey's team explaining its nature. Although Penzias and Wilson had never been looking for cosmic background radiation, didn't know what it was when they found it, and hadn't described it or interpreted the character in any paper, they received the 1978 Nobel Prize in Physics.
Wow.
The Princeton researchers got only sympathy. According to Dennis Overby in Lonely Hearts of the Cosmos, neither Penzias nor Wilson together understood the significance of what they had found until they read about it in the New York Times. Incidentally, disturbance of the cosmic background radiation is the thing we've all experienced. Tune your television to any channel it doesn't receive, and about 1% of the dancing static on screen is the ancient radiation from the Big Bang. The next time you complain that there's nothing on, remember, you can always watch The Birth of the Universe. Although everyone calls it the Big Bang, many books caution us not to think of it as an explosion in the conventional sense. It was rather a vast and sudden expansion on a whopping scale. So what caused it? One notion is that perhaps the singularity was a relic of our earlier collapsing universe. There were just on one eternal cycle of expanding, collapsing universes, like the bladder on an oxygen machine. Others attribute the Big Bang to what's called a false vacuum, or a scalar field, or a vacuum energy field. Some quality, something, at any rate, it introduced the measures to instability into nothingness that was. It seems impossible that you can get something for nothing, but in fact, there once was nothing, and now there is a universe. It's evident proof that you can. It may be that our universe is merely part of a larger universe, some different dimensions, and the Big Bangs are going on all over the time and all over the place. Or it may be that space and time had some other forms altogether before the Big Bang. Forms too alien for us to imagine that the Big Bang represents some sort of transition phase, where the universe went from a form we can't understand to one we almost can. These are very close to religious questions. Dr. Andre Linde, a cosmologist at Stanford, told the New York Times in 2001. The Big Bang theory isn't about the bang itself, but what happened after the bang. Not long after, mind you, doing a lot of math and watching carefully what goes on in a particle accelerator, scientists believe that they can look back to the 10 to the negative 43rd seconds after the moment of creation, when the universe was so small that you would need a microscope to find it. We mustn't swoon over every extraordinary number that comes before us, but perhaps worth latching onto from time to time, just to be reminded of how ungraspable and amazing breadth this event is. Thus, 10 to the negative 43rd is 1/10 millionth, trillionth of a second. Long time. So, Mr. Bryson goes on to conclude this chapter in saying, what is extraordinary from our point of view is how well tuned out it turned out for us in the universe. If the universe had formed just a tiny bit differently, if gravity were fractionally stronger or weaker, if expansion had proceeded just a little more slowly or swiftly, then there might never have been stable elements to make you and me and the ground we stand on. Had gravity been a trifle stronger, the universe itself might have collapsed into a badly erected tent, with precisely the right values to get to the right dimensions and density component parts. Had it been weaker, however, nothing would have coalesced. The universe would remain forever a dull and scattered void. So this is the beginning of the book about the sciences of the world. It is actually a very fascinating read. And I've actually mentioned the book before in one of my previous speeches, in which he talks about certain ways that the world could possibly end for us as we know it. The earth could end as we know it. But if any of you have any interest in it, I'm certainly loan the book to you. I think it's a very fascinating read. One would never have thought that the sciences could be written so eloquently and open for the interpretation of us non-scientific people. Well, thank you very much.